Hey everybody, in this video what we're going to do is we're going to continue on with trigonometry. Now you may have noticed that we didn't finish all the points in section 1, and here it says that we're in section 2. I'm going to be jumbling up the sections a little bit just because I think that there's a better order than what the book was going to have. So I think when you see the questions that we're doing in section 2, I feel like you would agree with me as well. Before we jump into those questions though, as promised, I wanted to give you a little bit of a quiz, and actually there's going to be a short one on the next slide as well. It should be a pretty simple quiz. If you saw the last video, you should know how to do this. So pause the video, match each trig function with its reciprocal. When you are done, start the video and I'll give you the answers. Okay, so remember from the last video that I told you match the cos with the no cos. So cotangent and tangent are super easy because they share pretty much the same name. Really the only tricky ones are the sine and cosine ones. So it's not supposed to be sine with cosine, but instead sine goes with cosecant, and then secant is going to match with cosine. And so those are the trig functions with their reciprocals. Remember we wrote it in the last video as sine of theta and cosecant of theta, cosine of theta with secant of theta, and then the last one, the easy one, tangent goes with cotangent. All right, now this one's going to be a little bit harder. Match all the trig functions with its equivalent form. So you've got the reciprocals, but then there's also some alternate forms. And note this second line, some of these are going to have more than one match. So go ahead, pause the video, again start matching up everything. When you are done, start the video again and I'll give you the answers. Okay, now that you've tried this, the first thing is I felt like I should at least show you the ones that were going to have more than one match. So I'm going to start with cotangent here. And I know that cotangent is the reciprocal of tangent, so those two are supposed to pair together. But then one thing I also know about tangent is that tangent is supposed to be sine over cosine. Well, the reciprocal of sine over cosine is cosine over sine. So therefore, those two have to go together. And then also cosine over sine is the same thing as cotangent. So that was going to be one of the pairs. Or I guess that's not a pair, that's a group of three. But so that was going to be one set of matches. Then if we've done that, we might as well move on to tangent, which we know is sine over cosine. And then we also know that tangent is going to be 1 over cotangent. So those three were going to go together. Then for the rest of these, they are pretty similar to what we had on the last slide, except instead of having you match, for example, sine with cosecant, I wanted you to see, if I choose a different color here, that sine was actually going to go with the same thing as 1 over cosecant. Those are equal to each other. And likewise, choosing another color, cosecant is going to be 1 over sine. And we can just continue on with finding the other pairs here. So let's see. 1 over cosine is going to be the same thing as secant. And I feel like I'm going to run out of colors if I'm not careful here. So what else have we not matched? We just have, actually we have pretty much everything. It's just 1 over secant is the same thing as cosine. That's the last one, because it looks like everything else has been matched up. And yes, I've gone around the circle. It looks like everything is. So that was how everything was supposed to match in this circle. Okay, so now we're going to get into the questions that were going to be similar to what we were doing in the prior video. Just being honest, Sabas loves writing questions like these. In IM3, when you get to their trigonometry chapters in term 3, you're going to see questions written like this as well. Fortunately, though, these really aren't too difficult. So what you're going to do is you're told that theta is an acute angle. Really, there's not any significance to knowing that it's acute right now. We're dealing with right triangles, and the two angles that are not the right angles, that one and that angle, they have to be acute. So really, there's no need for us to know that it was an acute angle. Now, the second part is that we're told these two ratios. Sine of theta is 7 over 25, and cosine of theta is 24 over 25. And we're supposed to find the other four trig ratios. Remember from the last lesson that we learned SOHCAHTOA. In the first part, we were told that sine of theta is equal to the opposite over the hypotenuse. So in this triangle, I'm going to go ahead and just mark theta wherever I want. And then we can take this triangle and label the three sides. We know that the adjacent is between theta and the right angle. Hypotenuse is the longest side across from the right angle. Opposite is across from theta. Therefore, we know, according to our fraction right there, the opposite was 7 and the hypotenuse had to be 25. Then for cosine, we were told that the adjacent is 24 and the hypotenuse is still 25 because cosine is adjacent over hypotenuse. Now, one thing that we can do to check to make sure that our numbers make sense is if we look at our triangle, the Pythagorean theorem is supposed to work. And we will get 7 squared plus 24 squared equals 25 squared. That's going to become 49 plus 576 is equal to 625. We get 625 on both sides. That's good. So we have set up the triangle correctly. Now that we've done that, we can go ahead and find these trig ratios. We were already given that sine was going to be 7 over 25. That's easy. We were already given that cosine was 24 over 25. That one is easy. So then it won't be an issue trying to find cosecant and secant because remember, those are the reciprocals of sine and cosine respectively. So 7 over 25 for sine means that cosecant is 25 over 7. If cosine of theta is 24 over 25, the reciprocal of that is going to give us secant of theta 25 over 24. The last one that we have is we just need to figure out tangent and cotangent. So there's a couple ways that we could find tangent and cotangent. The first way is remembering that tangent is sine over cosine. And if tangent is sine over cosine, then we could make the fraction 7 over 25 divided by 24 over 25. The denominators are both 25, so we could cross those off. And that would leave us with 7 over 24. Now that's not the only way that we could find 7 over 24 though, because another way that we could figure it out is from SOHCAHTOA. Tangent is the opposite over the adjacent. And if you look at our triangle, opposite was 7, 24 is the adjacent. That's another way that we could have found that our fraction is 7 over 24. Now that we have that fraction, cotangent is going to be easy because, again, it's just the reciprocal. So cotangent of theta is going to be 24 over 7. Okay, now I picked these numbers because this is actually going to be related to what we call the special right triangles. We're not going to learn about those yet today, but these numbers are going to be ones that you're going to see very often both this year in trigonometry and then also in IM3 for trigonometry. So we are given a similar question as before we should make ourselves a right triangle. Just pick an angle for theta, doesn't matter which one as long as you're not picking the right angle. And then we should go ahead and fill in the values that we were given. So again, here's the adjacent, here's the opposite, here's the hypotenuse. Sine is going to be opposite over hypotenuse. So that means that we're going to have square root of 3 as the height, and we're going to have 2 as the hypotenuse. Then cosine is adjacent over hypotenuse. So we have 1 over 2. There's the 1 as the adjacent side. We still have 2 as the hypotenuse. I'm just going to fill in the rest of SOHCAHTOA there. Now, you are not required to check if the Pythagorean theorem works, but again, it's good practice just to make sure that everything is correct before you try to finish solving it. We're going to get 1 plus 3 equals 4, and we can already tell that's going to work. So yes, we did set up our triangle correctly. One thing I noticed though, it is possible that you might set up these two in the wrong spots. Perhaps you may put square root of 3 over there and you put 1 over here. In that case, yes, that is going to be an issue where Pythagorean theorem is going to be correct, but you have them in the wrong spots. But hopefully you're getting good at identifying where is the opposite side and where is the adjacent side so you can avoid that issue. Okay, once again, we were given sine and cosine already. We know sine is going to be square root of 3 over 2. We know cosine is going to be 1 over 2. So when we find, I'm going to move that a little higher. When we find then our reciprocal for sine, now the reciprocal we start with is of course going to be just 2 over root 3. I want you to be aware that we really should be rationalizing our denominator. And so that was where we multiplied the top and bottom by the square root so that we are able to get rid of the square root in the denominator. That means that up on the top we're going to have 2 root 3. Down at the bottom, square root of 3 times square root of 3 becomes square root of 9. And we know that the square root of 9 is 3. So this is how we should be writing our answer then for cosecant of theta. For cosine of theta then, it's 1/2. That one's going to be easier. We know that secant of theta, the reciprocal, is just going to be 2 over 1, so that's 2. And then lastly, for tangent, it is opposite over adjacent. So in this picture, it's going to be square root of 3 over 1, or just square root of 3. And then for cotangent of theta, the reciprocal is going to be 1 over square root of 3. But remember, we should also be rationalizing this denominator. And we really should have it as square root of 3 over 3. Okay, now that I've shown you a couple of these, I want you to try this one on your own. My hint for you, by the way, now you're given decimals, turn them into fractions, and then this question becomes a lot easier for you. You can simplify your fractions if you want. It's not required. Well, initially it's not required, but when you find these values down here, it should be simplified. So pause the video, give this a shot, and then when you are done, I will show you how to solve it. Alright, so again, my hint that I gave you was that you should be trying to turn these numbers here into fractions, and then this question becomes a lot easier for us to solve. So we know that 0.6 is 6/10, and then if we simplify that, that's 3/5. So I'm just going to go ahead and write in sine was 3/5. Now for cosine, that is 8/10, and we're able to simplify 8/10 to become 4/5. So I'm going to put that in for cosine. Now we can make our triangle, and sine was 3/5. Now this is the part where I was saying it didn't really matter before you paused. If you decide to write this as 6, and if you decide to write this as 10, that's perfectly fine. You're still going to get the same answer. Just know that you need to simplify your fractions at the end. Alright, from cosine then, we know adjacent over hypotenuse, that would have been 4 in the denominator. 4, excuse me, 4 at the bottom of the triangle is what I meant to say. We've got all of our information. We can go ahead and fill in the rest of this. Tangent is going to be opposite over adjacent, so that is 3 over 4. Then we just need our reciprocals. Cosecant is 5/3, secant is 5/4, and lastly cotangent is 4/3. And that is everything, everybody. So this assignment is not as deceptive as the prior video's assignment. This one is actually shorter. I think I'm going to have you do 2 out of the 3 that I'm assigning. So just check Schoology to figure out whichever ones I've chosen. Thank you for watching. Have a good day.